All right, welcome back. We're jumping into part 4 of our deep dive on process control, based on the work of Muhammad Ajaluni. So you've got a stable, predictable process. That's great. But here's the big question. Is it actually any good? Does it do what the customer needs? That's what we're tackling today.
First, let's do a super quick refresh. In our last explainer, we broke down the two kinds of variation, and we introduced the process behavior chart. Think of it like a detective. It helps us separate that normal, everyday background noise, what we call common cause variation, from the real signals, the assignable causes, that tell you something is actually changed. And that is how we figure out if a process is in statistical control.
And we really zeroed in on the power of that chart, which you'll often hear called the XMR chart. The key thing to remember is just how practical it is. You don't need your data to fit into a perfect bell curve or anything like that. You can just use it. That makes it a total game changer for real-world situations.
Okay, so all that predictability brings us to the big question. Just because a process is stable, just because you know what it's going to do tomorrow, does that automatically mean it's good? I mean, you could have a process that is predictably making bad parts, right? So this is what we're digging into today, how we bridge the gap between knowing how our process behaves and knowing if it's actually delivering what our customers want.
And to figure that out, we have to listen to two very different voices. First, you have the voice of the process. That's the data, what the process is actually doing, what it's capable of. And then you have the voice of the customer. That's what they're asking for, what they need from you.
And this table here is perfect. It puts those two voices right next to each other so we can compare. Look at the top part. That's the customer talking. They want a target of exactly 12 millimeters, and they'll accept anything between 10 and 14. Now look at the bottom part. That's our process. It's averaging 11.98. Pretty darn close. And its natural limits, its normal wiggle room, runs between 10.60 and 13.35.
Okay, now this histogram really paints the picture, doesn't it? That bell curve in the middle? That's us. That's the voice of our process. And see those two vertical lines on the outside? Those are the customer's goalposts, their specification limits. And look, our process fits right inside with room to spare. This is exactly what you want to see.
So when you see that, when a predictable process lives entirely inside the customer's specs, we get to use a special word. We call that process capable. And that's a huge deal. It means, hey, as long as we don't mess with anything, this process is just going to keep churning out good parts that meet the requirements. But, capable is a great word, but it's not a number, and we really need numbers to manage things properly. So how do we actually measure this capability? Well, that leads us straight to our first key metric, which is all about measuring the potential of the process. It's called the Process Capability Index, or just CP for short. And honestly, it's just a simple ratio that asks a really simple question. How wide are the customer's requirements compared to how wide our process variation actually is? And the math is beautifully simple. You just take the total width of the customer's tolerance. That's the upper spec minus the lower spec. Then you divide that by the total width of your process, the upper natural limit minus the lower natural limit. It's the voice of the customer divided by the voice of the process. That's it. So for our example, when you crunch those numbers, you get 1.45. And notice, it's not 1.45 millimeters or anything like that, it's just 1.45. The units cancel out, so it's a pure number, which makes it really easy to compare across different processes. So what does that number, 1.45, actually mean? Well, here's the cheat sheet. Anything over 1.0 means your process can fit inside the specs, so it's capable. A lot of industries look for something around 1.3 or higher as a sign of a good process. So our 1.45? That's fantastic. It means we have a ton of elbow room, a nice safety buffer on either side. Okay, but hold on. There's a little bit of a catch with CP. It's a great metric, but it only tells you about potential. It answers the question, is my process spread narrow enough? And it kind of assumes your process is perfectly centered on the target. But what if it isn't? What about reality? And this is the key difference right here. Think of it like parking a car. CP tells you if your car is small enough to fit in the parking space. Great. But CPK tells you if you've actually parked it between the lines. CP is about potential, the size of the car. CPK is about reality, where you actually parked it. So CPK gives us that reality check. The way it works is it looks at your process average, and it measures the distance to the upper spec limit, and then it measures the distance to the lower spec limit. After that, it just tells you the smaller of those two distances. It's basically a worst-case scenario number showing you exactly how close you are to the nearest danger zone. Now, this is super important, so I want to make sure this is crystal clear. You can only use CP and CPK if your process is predictable, if it's in statistical control. They are meaningless otherwise. So that raises a pretty big question. What in the world do you do for an unpredictable process?
Right. If your process is all over the place, if it's jumping around because of those assignable causes, then talking about capability makes no sense. It's like trying to predict the future with a broken crystal ball. So for those chaotic processes, we stop talking about capability and we start talking about performance.
And this is the absolute key takeaway. Capability, that's CP and CPK, is for stable processes only. It's a forward-looking metric. It predicts the future. Performance, that's PP and PPK, is for any process, stable or not. It's a backward-looking metric. It's a report card on what has already happened. It's the difference between a weather forecast and a history book.
So let's bring it back to our example. We know that process was predictable and stable, right? Well, if we were to calculate its performance index, its PP, we'd get 1.73. Now compare that to the CP of 1.45. See how they're pretty close? That's a classic sign of a stable process. When capability and performance numbers are hanging out in the same neighborhood, you know you're in a good, predictable spot.
Okay, so we've been through a lot here. Variation, limits, capability, performance. All these concepts, they're not just numbers on a page. They're all building up to a really profound but simple way of thinking about quality.
So after all these calculations, what are we really trying to do here? What is the end game?
It's this. Quality is achieving the target with minimum variation. That's it. It's not just about staying within the lines. It's about hitting the bullseye over and over and over again, as consistently as humanly possible.
And that's the big idea I want to leave you with today. Think about our process. That CPK of 1.45, it's really good. The process is capable. But what that number also tells us is that there's still elbow room. There's still room for improvement. So just because your process is capable, does that mean you should stop? No way. That's where the real work begins. We'll get into that next time. Thanks for joining us.